hello folks, nice to see everyone here. I was actually saying to people earlier, it's been about 13 years since I was last in New York, so I did the very Scottish thing yesterday and said to myself, I'm going to go around and see the sights in Manhattan today. It's been a while. And of course, I did that in the true Scottish way, so I just walked the whole time. 16 miles later, somewhat regretting that decision today, so I'm not going to be moving around the stage very much. So this is the title of the talk, Growing Pains, Portal Gains. It's our journey at Skyscanner, to take you a little bit more into that. But first, my name's Stuart. I'm a senior engineering manager at Skyscanner. I work in our platform engineering team. I've worked at Skyscanner for over 11 years now, starting out as an engineer in our database infrastructure and data center operations teams. After 6 years or so, I transitioned to that leadership role through our own internal engineering manager program. So today, I want to take you on that journey of Skyscanner's evolution over the last decade, where we'll look at some of the key changes in our organizational structure, our technology, and our culture, and how those changes have helped us balance growth, speed, and responsibility. We'll also look at how these changes have made it necessary for us to work more efficiently and some of the productivity challenges we've faced along the way. So, who are Skyscanner? For those of you who don't know, well, we started life as a simple spreadsheet of all things, and that was in Edinburgh in Scotland in 2003. Our goal was to help travelers find the best flights. In fact, it was actually a side project for one of our founders who was always on the lookout for their next ski holiday. Today, we're a global leader in travel, connecting over 110 million users every month to over 1,200 travel partners. We use technology to make travel easier, and we search more than 80 billion prices every day so that travelers can find the best deals all in one place. Our growth has come with many different challenges over these years, and not just with engineering and technology, but also with people, process, and productivity. So in those earlier years, and until around 2013, Skyscanner was organized in a traditional siloed way. We had large teams responsible for whole product areas like flights, hotels, and car hire, and other core functions such as infrastructure, database operations, and testing. These types of organizational silos tend to come with a bit of a bad reputation, but they do have some benefits, or they did have some benefits for us. And like everything, it's about finding that right balance. At this time, most of our services were deployed, built using proprietary software, and were deployed in traditional data centers around the world. We had specialized development teams working on their own front-end and back-end code. Our infrastructure teams were responsible for the smooth running of our platform and operations, including our capacity planning to keep up with the growing demand. Our database operations teams ensured that our data stores were healthy and that the different parts of our data processing pipelines were running efficiently. And our testing teams ensured that any new features being developed were thoroughly checked and tested for regressions across the different devices that we supported. At this time, improving developer productivity or engineering efficiency wasn't really top of mind. Our main focus was continuing to grow the business and make sure we were sustainable in the long term. And that was okay, because we had specialized teams who were the experts in their areas, and they were focused on the problems that they needed to solve. Everyone had really clear responsibilities, as our ownership model and boundaries were really well defined, and we really didn't have that many moving parts in terms of individual services or components. So I did say the organizational silos were a balance, and while things were okay, they weren't great. We didn't collaborate very well across these siloed teams, and requirements or dependencies would occasionally be missed. Changes were also harder to implement, often requiring huge refactors of code that just needed lots of testing before getting anywhere near production. And even with very focused and efficient teams, it was still incredibly difficult to get everyone moving fast together. This way of working led to big bang releases of code every 6 to 8 weeks, quite literally all or nothing. There was an excitement about those major releases, though, but it took a huge amount of coordination and effort to even get there. So looking back now, it's clear that that was a pretty inefficient way of working, but we made it work for us at the time. As an engineering team, we just did what needed to be done, no matter how easy or hard something was. And to our own credit, it did get us through some of those earlier periods of accelerated growth. The real cost of this way of working for us was our speed of iteration. We couldn't deliver incremental value to our travelers or partners iteratively or quickly. And at the time, we were a really small player in a much bigger market. Now, we knew we wouldn't keep growing that fast forever, so we needed to work smarter, be able to stay ahead of our competitors, and become that top 100 global consumer product that we aspired to be. So something had to change. In 2014, we made a big change to our organizational structure. Inspired by Spotify, we adopted a tribe and squad agile structure. We took a few groups of people from our product engineering teams and made them into squads. We empowered them with greater autonomy and encouraged transparency and a focus on continuous improvement through experimentation and sharing learnings from both their successes and failures. Their goal was to figure out how to deliver value incrementally. This was the beginning of our journey to break our monolith, at least in terms of organizational structure. So we restructured some of our teams into squads and gave them more freedom to make decisions and move quickly, each of them taking full responsibility for their product area. To set these squads up for success, we also started improving our engineering processes, focusing on scaling up our operations and then speeding up software delivery with things like CI and CD. We automated more of our work and cut down on the manual steps required to release code. We also started looking at how we might move to the cloud to understand how these engineering processes might need to adapt, but our data center operations remained crucial to the Skyscanner platform at this time. So although we didn't commit to a cloud transformation at the time, the investments we did make in more modern engineering practices, as well as our change to tribes and squads, were starting to pay off. We were able to experiment and deliver improvements to travelers and partners more efficiently. Our speed of iteration was starting to improve. But these benefits didn't come without some challenges. We now had a lot more squads working independently from the rest of engineering and shared ownership of what were still mostly large, complex, monolithic systems created a more complex ownership model. Our smaller squads were also spread out across different locations, which highlighted that we needed to establish better ways of working and tools to be more efficient. It was also harder to coordinate changes between our new agile squads and our older monolithic teams because there wasn't always clear boundaries between them and one could move faster than the other. Our improved CI and CD capabilities were great, but they also led to more problems in production. We were releasing code faster, after all, but our smaller squads didn't always have the necessary skills or experience to write comprehensive tests that encompassed a complex monolithic code base. And it was sometimes hard to find the people responsible to fix those problems because of the changing organizational landscape. As if this wasn't enough, at the time we were also facing frequent problems with capacity in our data centers, and it was clear we were beginning to run up against the economies of scale. So our speed of iteration had improved, but that wasn't enough on its own to address the growing problems we had with our operations and the impact that was having on our travelers and our partners. So we needed to improve our balance of growth, speed, and responsibility, and by investing more in our engineering platform and tooling for developers. Fast forward to 2016, we committed to significant change to our technology and culture to help us grow faster and give our engineering platform some much-needed breathing space. Our plan was to fully break the monolith into separate services and components, adopt a true DevOps mindset and culture, and modernize the Skyscanner platform using cloud technology. Our former CEO said it best when he described it as the largest transformation of our core technology platform in our history. And he wasn't wrong. At this point, most of Skyscanner was now made up of tribes and squads, and we announced we were moving to a cloud-first open source model, adopting a microservices architecture and other DevOps practices like infrastructure as code. To support this initiative, we relaunched our engineering principles and published our first cloud-native design standards to help guide our squads. Our goal was for engineers to create and deploy a new microservice in AWS in just 10 minutes, and our newly founded developer enablement tribe would support that goal. To achieve this, we needed to set some sensible defaults for engineering. So we created the M-Shell squad, short for microservice shell. Their job was to make it easier to build, deploy, and operate microservices in AWS. To do this, the M-Shell squad provided developer tools to create templated microservices with essential features like blue-green deployments, event logging, and health checking. So we placed our bets on containerized microservices to make it easier to develop locally, get faster feedback, and deploy safely, which would naturally lead to better and more reliable systems. So with these foundations and our more scalable cloud infrastructure, plus those previous investments in CI and CD, we were now ready for much larger operations. However, this technology transformation wasn't entirely straightforward. Breaking the monolith was a relentless task. We rewrote whole parts of our stack from scratch. We ported applications to the cloud, and we simply lifted and shifted others. This created years of technical debt. And during this transformation, we relied on both on-premise and cloud infrastructure, connected by a spider's web of direct connections to maintain connectivity and ensure redundancy, which only added further complexity to our architecture. Most of all, this transition required a huge amount of learning for our engineers. They were now responsible for building, deploying, testing, and operating distributed systems at scale using cloud technology, and we were quickly learning about the fallacies of distributed computing. So we continued our journey to the cloud in pursuit of achieving world-class engineering at scale, and we'd removed many of the barriers that had once slowed down our engineering teams, so we were more productive and had a good balance of growth and speed. Our squads had embraced the new freedoms that they had of their services and infrastructure, but we still fell short in our responsibility to serve travelers and partners by ensuring we provided a reliable and available service. So, it was now December 2018, and we'd finally done it. We'd moved all Skyscanner services to AWS and shut down our data centers. It was a huge milestone. To make this happen and reinforce that responsibility for operating reliable production systems at scale, we'd embraced the you build it, you run it philosophy, famously coined by Amazon CTO Werner Vogels. We used this philosophy to bridge the remaining gaps between development and operations. Importantly, we used it to help shorten the feedback cycle between user experience issues and a team's awareness and priority to fix that issue. We gave squads better tools and visibility of how their systems were performing and to get alerts when things weren't right. We invested in on-call for all engineering squads, which also meant we had to be better prepared with clear runbooks and good documentation. All of these things helped improve our services, our availability, and our instant detection and response times. This was the level of responsibility that we owed our travelers and partners for relying on us. However, after a lengthy cloud transformation and a move to tribes and squads, our engineers already had a lot more on their plates. They were now responsible for both building software and keeping it running smoothly. And while our agile squads had given engineers more freedoms and responsibility, it also meant that they needed to work together better. We tried encouraging them to embrace inner source and share ideas through practices like design reviews, reusing code, and knowledge sharing. But it still felt like these smaller squads were now just smaller silos. And with so many squads working on different things, it was getting harder to keep track of everything that was happening and the details of all the different services and components being developed. So we needed a better way to track who was responsible for what software was being used, did any of it need to comply with specific regulations, and how were we going to ensure that it was all maintained in line with our production standards. This is when we started to invest further in our enablement tooling. Firstly, we created a tool called Surveyor, which would scan our GitHub repos and gather information like what languages were used, what libraries were used, and other useful metadata. Then we created a tool called CodeLift. CodeLift could automatically create pull requests to keep our repos up to date. It could be used for things like simple version bumps, or it could be used to run more complex campaigns to bulk update blocks of code across any number of repos. Then we wanted to enhance our repo metadata and be able to answer more complex queries like, does this service need out-of-hours support? Does this service handle personal data? So we introduced a file called the catalog YAML. And every repo had to have that file in it. It was a mandatory ask for engineering. Getting this catalog file merged into every active Skyscanner repository at the time was the real challenge. So we ended up creating a tool for that too, and we called it Flightworthy. Flightworthy would check for the existence of the catalog file, and if it didn't exist, or if it wasn't valid, it would fail its check, and you wouldn't be able to commit your code. To keep an eye on our code health and security, we created a tool called Talos. Talos would track changes to your repos over time, and it would tell engineers if they were running out-of-date libraries or unsupported Docker images and give that repo a security score. And finally, to put all of this information into one place, we built a tool called Tower. Tower let us search our components and our services and the various links to our other services. Tower was basically the first iteration of our own IDP. From here, our intent was to expand Tower into a bigger, better, fully featured developer portal. At least, that's what we'd hoped. In 2019, we were talking to Spotify about an internal tool they had called System-Z, which is now better known as Backstage. We liked the idea of Tower being something similar, a foundation for an extensible, reusable internal tools platform. But the developer enablement tribe was also busy with other things, like building the next iteration of the Skyscanner platform on AWS. So we didn't have as much time to focus on improving these tools for developers. And another issue was that engineering squads now had a lot more freedoms to simply design and build their own services using AWS. These freedoms were great for being able to move fast, but it also meant we had a bunch of different tools popping up across the organization. It was faster to build something new than it was to wait for a central solution. It wasn't all bad, though. Our squads built some really good tools. We built tools that integrated with our experimentation platform to manage our partner integrations or for surfacing operational excellence issues, like identifying unowned AWS resources that didn't map to something in our service catalog. These tools streamlined tasks, they provided faster feedback to engineers, and they surfaced operational issues for us to investigate. In one way or another, they were all trying to improve our engineering productivity and operational excellence. The downside was none of these tools were unified, and a lack of standardization created a fragmented ecosystem that required engineers to navigate multiple different systems for information. Maintaining these tools was also hard. They were like side projects in already much smaller squads, where they were often neglected or defunded due to competing priorities across the different business areas. Trying to improve these tools was also challenging. It was a bit like trying to insert a new stage into a Rube Goldberg machine that always seemed more complicated than it needed to be. Worst of all, none of these tools provided comprehensive automation and reporting on the maturity of our production standards, or where our software delivery bottlenecks were. And although our operational excellence practices had improved, they lacked a true sense of centralized governance, making prioritization in alignment with other engineering initiatives more challenging. Inevitably, all of these new systems, processes, and information left our engineering teams feeling a bit like this. We've tried to give them more and more information, but now we've overloaded them by adding too much to the already much higher cognitive load, slowing our engineering productivity further. The disjointed information has made it harder for those teams to focus and get things done, and with no clear direction on the priorities between them all, it's hard to know where to start. So, that brings us to 2024. In July this year, we brought in Cortex to be our internal developer portal platform. Since its launch, over 600 engineers and product people have access to the platform. I want to say a huge thank you to the Cortex team for helping coordinate and facilitate our enablement workshops, some of which have been across quite tricky time zones, particularly with our engineering base in China. Although we're still in the early stages of adopting Cortex at Skyscanner, it's already inspired a new way of thinking across our engineering and leadership teams. And we've already seen some early benefits of integrating with the platform. We launched Cortex with two initial scorecards, one for catalog data validation and another to measure the maturity of our production standard for CI. We wanted these initial scorecards to provide engineering with an introduction to how scorecards work, what teams need to do to resolve action items, while being relevant to a current engineering initiative, in this case, our adoption of GitHub Actions for CI. The catalog data validation scorecard instantly revealed unnecessary complexity in our own catalog definitions, plus inconsistencies in the ownership and other metadata fields, prompting us to simplify our catalog schema and enrich that data. The CI scorecard provided valuable insights into our GitHub Actions adoption progress, and we get the bird's eye reporting out of the box, so we no longer needed the manual spreadsheets and custom repository scanning tools we created and maintained for tracking that adoption. And finally, we're in the process of revamping the rest of our production standards to ensure better consistency and alignment with Cortex, building upon our learnings from our production standard for CI. Moving forward, we'll continue refining our production standards, ensuring they're measurable and reintroduced across engineering in a way that doesn't add to the cognitive load. We're also going to simplify and remove some of our custom tooling and reporting by leveraging scorecards for operational excellence areas such as security, operational maturity, or service levels. We'll also continue to enhance our catalog, our developer homepage, and team views to provide a truly unified single pane of glass for other key information, such as the AWS resources linked to your projects, or what your cloud billing costs are. And finally, we'll explore Cortex initiatives to help establish more sustainable work planning, coordination, and adoption of newer updated practices or standards. And we hope to achieve all of this by focusing on three key pillars. Our first pillar is improving production readiness, where we will use Cortex to help our teams understand the maturity of compliance for the standards, for the services that they own, and how they can improve those maturity scores. By improving our adherence to standards, this will help reduce change failures because it minimizes the release of code that is incompatible with our underlying infrastructure or platform, leading to even better products for our customers. Our second pillar is ensuring higher quality through operational excellence, where we can use Cortex to provide clear prioritization of non-functional OpEx topics, such as security, cost management, or service levels. By providing clearer prioritization of specific focus areas, we can simplify the workflows for adopting new or updated practices or standards. This will provide engineers with a direct view of what is important, how to adopt it, and the status of that adoption relative to their services. And finally, our third pillar is increasing developer productivity, where we can use Cortex to provide a central, accessible location for holistic performance metrics, allowing us to better understand the bottlenecks in our software delivery, as well as consolidating our engineering tools into a single pane of glass to improve efficiency and collaboration. By driving key insights and signals to engineers through that single pane of glass, we can reduce the cognitive load and improve our engineering productivity. So, to recap, our journey to reach this point has been a long one, marked by very thoughtful and deliberate transformations, moving from a siloed organizational model to tribes and squads, empowering our engineers with greater autonomy and improving our speed of iteration so we could deliver value incrementally. Then undergoing a cloud transformation to break the Skyscanner monolith, enabling us to work towards achieving world-class engineering at scale, taking us from that 6 to 8 week release cycle to where we are today, over 1,000 deployments a day. Then embracing new ways of working across engineering with the you build it, you run it philosophy, helping to close the final gaps between development and operations that underpin our DevOps culture, improving our balance of growth, speed, and responsibility. These changes reflect Skyscanner's evolution over time and have been shaped by our own learnings, both successes and failures. So as we start on this next stage of our evolution, we'll be using Cortex as our IDP to help us get there. Thank you very much for listening.
Thanks for the talk. Sounds, a lot of them were very familiar. I was like, oh my God, this is so close to my heart. While talking about the monolith in the data center and getting new services in AWS, you mentioned something about sensible defaults. Could you elaborate on what kinds of sensible defaults you all had to use?
Yeah, so I guess there are many, but sort of the top ones that come to mind, apart from having the templated sort of microservices, were choosing a set of common languages that we would use across engineering. So we settled on 3. So Java, Node, and Python were our main 3 languages. And that gave us other additional benefits as it limited and constrained the amount of effort that we had to invest in maintaining those for the rest of engineering as well. So outside of the templating and the standard set of languages that we would publish across engineering, that's probably the two main ones.
Sorry, I go first. So to that point of templated microservices, what do you all do when you update a template? So you've already scaffolded some microservices, say it's your Go microservices.
Yep.
Folks have spun up new Go services, and now you update the template with new standards.
Yeah.
How do you all think about updating the existing ones?
So majority of the time for us, it's creating pull requests for the teams, the owning teams of those services to bring their service up to speed. We don't have a great solution for doing that for them because we've got so many services distributed across the organization. It's impossible for a central team to do that for everyone. So our usual approach is to do as much of the heavy lifting as we can ourselves. But at the end of the day, there's always an ask out to the organization to help kind of keep things up to date. One of the things we will be using Cortex for is to help sort of visualize and be able to track those kind of changes. So if we bump version of Java from one version to the next, we can kind of get that nice view across engineering of who's done that, who's still to go, and actually have that as a running initiative across the org.
At the tail end, I heard you drop 1,000 deployments a day. Can you talk about the evolution? Like, how did that evolve over time? Do you correlate it with the platform development?
Yeah, so I guess a few things in there. So getting out of that original 6 to 8 week epic release cycle that we once had. So in the middle there, we built our own deployment solution that sort of coordinated the blue-green deployments for us. That happened around the same time as we were moving to containerized microservices as well. So again, it was the whole system built around being able to safely deploy containers. Really, scaling that up or scaling that out to the rest of the organization was getting everybody to use that common platform for developing their services. So going back to the point about having everybody use containerized microservices in the first place, definitely played into that. And over time, we've just simply scaled up that operation. We've evolved that deployment platform to do more than containers. It does our infrastructure for us now. It does a bunch of other AWS-related components that we deploy frequently, as well as some other components around the business. So we've naturally built on top of that over the past few years.
Every 6 weeks, so 2 times a quarter?
Yeah.
2,000 times a day?
6 to 8 weeks. 6 to 8 weeks.
Hey, Thank you for the talk. I was curious. It seemed like you went through a big evolution since the start of Skyscanner to today, where you've introduced Cortex. How much of that was mandated change to the rest of the engineering department versus actually a pull relationship, or maybe you saw that they needed a change? And yeah, I hope you understand the question. Like, what was the balance essentially between you telling people this is not what we're going to do, and you noticing that there is a problem that needs to be solved?
Yeah. I think at the time, there was a very, very strong desire from everyone in the business to continue that growth. And I think that the problems we were facing, particularly with our data centers at the time, was very, very visible. We really, really wanted to do something about that. And we knew at the same time, expanding those data centers wasn't a cost-effective way for us to do that either. So our other alternative was using or moving to the cloud, where we could kind of embrace that supposedly infinite scale. It's not quite infinite, but that was, I guess, a bit of an appealing factor for the teams as well, because although it was a huge amount of learning, it was great for their own kind of personal development there as well, being able to kind of use new technologies and kind of learn more about cloud computing as well. So yeah, all the other changes as well, not an awful lot of top-down decision-making, more like a shared decision-making across our engineering teams, which also includes exec level as well, but everybody was on the same ground for that.